All right. So last time we got our game into a position where we can hit start. We have our beautiful grass. We hit start, and we have our distance and our ball going at the same time. And we'd like to have those two linked together in some way, right? All right, so at the end of class, there was a suggestion, I think, what were we constraining the X? What was the suggestion right at the end of class?
Follow the distance. Marker instead of the golf ball. Just like when it reaches the end of the screen, the camera scrolls with it instead of the golf ball.
Oh, have this guy be the distance and have the golf ball, or have the camera follow this guy and have the golf ball drag him.
Mm-hmm.
Okay. Or have him drag the golf ball, I guess.
Right.
So we go into golf ball. Remove control camera from here. Then go into our distance. Add control camera there. And let's just see the behavior we get with that. Didn't we have this issue last time? What did we need to do to make control camera work? Well, let's go to our scene.
Increase the size.
Yeah, well, that was a theory, but I don't think we actually... I don't think that actually panned out. In fact, I think the problem is he's not here today.
Yeah.
The one who figured it out. It's not his...
Pretty sure we had to add it into the instance itself. Yeah,
His camera's not in there.
No, that does make sense. Okay, so we just needed to let him still be on the screen, right?
Mm-hmm.
So that means we need to go into our camera for our scene. Change the tracking area to maybe be, let's do 450. Okay, that looks pretty legit, right? Okay, now, and we have our golf ball being destroyed upon landing for right now, which is fine for what we're trying to accomplish, but eventually we want to take into account rollout. But so now we need to have distance count up, but we want it to count up on yards. So now we got to think about converting between some different measurements. Our golf ball. So at some point we're going to have to give a unit of measurement to pixels. We're going to have to decide as our golf ball is traveling across X, so many pixels, what is the translation of that distance to yards? Okay. Now, how do we actually figure that out? We have to go backwards. So I'm telling you that when this golf ball gets launched, at that speed and that angle, this ball probably traveled around 220 yards in the air or something like that, 230 yards in the air. So that's how far I'm telling you that ball likely traveled based on my experience. But we need to now extrapolate how those pixels add up to yards. How would we solve that problem?
we need to convert the units that they're using, which we currently have as miles per hour in our own minds,
Okay.
into yards per second.
Okay. So we have miles per hour. So if we go back to this guy, this unit of measurement is miles per hour, correct? All right. And as we're launching up, it's still traveling at some miles per hour, but this is a speed that, well, as of right now, is constant. And we're going to leave it as a constant speed for right now, even though we know that it will have slowed down as it flies through the air due to friction and stuff like that. Okay, so we have miles per hour, and at the time that it hits the ground, we need to calculate how many yards. For starters, why don't we calculate how many miles? That should be the easier thing to do because we already have it in miles per hour, right? So miles per hour is going to translate into what? It's going to be, we'll divide it by 60 to get miles per second, then divide it by 60 again, or miles per minute, then divide it by 60 again to get miles per second, correct? Question is this guy flying every second? Or is at least that's what we're going to have a timer go, right? So inside of our distance, we may have a timer. And we're going to say that this timer does something every 1 second. And what's it going to do every 1 second? It's going to update its distance. So we need to add an attribute associated with this guy to be current distance. Okay? We might end up making this global, but let's just make it local for right now. So we'll have this guy be an integer. We'll call this guy cur distance. We'll start off at 0. So every 1 second, we want cur distance to go up by whatever the velocity was. Okay, so the 120 miles per hour, which is a game attribute, right? So at our game, we have some attributes, and one of those attributes is current ball speed. Okay, so we want to grab the current ball speed. Actually, I think we need to make these changes inside of our instance, if that's where we did the control camera. Otherwise, we're putting all this stuff into the prototype, and the prototype isn't what exists in our game because the control camera is associated with that instance. And we talked about that a little bit last time, where if we're only going to have a guy live in the scene once, it's fine to put him in there and edit the instance. But if we're going to be making multiple copies of these guys, so think Mario, where you have the little turtle guys and you have the little mushroom guys. There's a zillion of those, right? And they're all the same. They all act the same. Those are things you would create at the prototype level, and then you just keep spawning them into the scene. Okay, and we'll deal with spawning things here in a little bit. If not today, definitely on Monday. So we're going to go ahead and put that timer in here. We'll say every 1 second we're going to do what? We're going to update our current distance variable. And what are we going to update it to? So this particular guy's current distance is going to be equal to whatever it currently is, plus our game's current ball speed divided by 60 divided by 60. That's how many miles it travels in a second. That make sense? Okay. And that happens every 1 second. Now, as of right now, this timer, we're going to need to hit our start button real quick because this timer just starts. Okay? We're going to want this timer to start as soon as we hit that start button. For right now, just to make sure it's making its updates, which it's not. Oh, it's because I have this. Well, here. It is because I have that, but I'm not displaying the current distance, which is what all of you said. I think so.
to display for current distance to be the difference between the starting point and the current point, and then the x.
Well, you could, but that shouldn't make a difference as to whether or not this is updating. What if we threw our display text in here? I see it flashing in there.
Yeah, 0.
It just kept flashing a 0.
Kept flashing 0.
Let me do something here. I'm going to come into our... Well, that's actually interesting. You cannot add an attribute at the instance level. All attributes have to be added at the prototype level. So that's why this guy came in. So at least, at the very least, in terms of attributes, all of these actors need to be identical. So we are updating cur distance. We're setting cur distance to be whatever it currently is plus something. So I mean, even if we just simplify this whole thing over here, just say plus 5. Okay, so that's bumping. So the issue is that our math was just out of curiosity. Oh, wait a minute. We need to make this guy not an integer. We need to make him a real. Can I change it here? Nope. So we're going to remove him, add a new one. We're going to make him a real number, which seems weird because before we've seen integers display with a bunch of decimal places.
Could have just been the way you entered before.
So we'll start that off at 0.0. Come back into our distance. We're going to change our cur distance to be let's just do that for a second. We'll add 5.25 to it. Oh, we're not displaying it yet. Even though we named the variable the same thing, it technically became a new variable. Okay. So now we'll actually do the right math in here. So I'll add to it our games, current ball speed, divided by 60, divided by 60. Why is this staying at a 0?
Current ball speed is set until you click start.
Oh. Well, good. Then it works the way I intended. Okay, so we traveled, what was it, about 0.3 miles? Is that what it was? 0.3?
0.33.
Okay, so what is miles to yards? .3 miles in yards. Well, that's a big drive. 528 yards. But the good news is it is somewhat in the ballpark of like reasonable. I mean, that's a big drive. Okay, but at least it didn't come out to like 1,700 yards or something like that. Okay, so let's look at miles to yards conversion. So it can actually give us the numbers.
Wow, 1760.
So miles times 1760.
So we just got to multiply this by
it's still trucking up there.
Yeah.
Actually, this is probably reasonable because at this point, our 120 miles per hour is not slowing down.
No, and it's in a vacuum.
So
there's
in
no
so in
energy.
real life, that 120 miles per hour. I mean, this is how long with gravity does 120 miles an hour sustained speed take to finally drop back to Earth?
Right.
Where in real life, that's going to be slowing down. So 528 yards or whatever it was isn't necessarily unreasonable. Okay, so 1760 is our conversion. So why don't we just take that number and multiply it by 1760. So we'll always just be adding on yards.
Mm-hmm.
Yeah, that's not horrible. Okay, so now we are going to want that guy to stop though.
Yeah.
So how do we make our timer stop?
It need to be in the golf ball when it collided. Put in another then for making this stop, for making that timer stop.
Okay. Now, as of right now, our golf ball is being destroyed when it lands, correct?
Mm-hmm.
So the question is, if an object gets destroyed, would a timer housed within that object also be destroyed?
Yeah.
Seems likely, correct? Okay, so let's implement it that way. But in order to make that work, since we want our distance guy to show the variable, to show the distance, we're going to have to make this a game variable, right? So we're going to go in. Let's go to our game. We'll add an actor, then delete it, just to refresh how to delete an actor. Just shut up. Okay. So then we'll come in here.
TGIF.
What was I talking about? Current distance. And that's a real. We'll start it off at 0. Okay, so this is a game attribute now. Just so we don't forget, let's go back into our distance and let's remove that attribute. No longer applies, right? Okay. Now we're going to go into our golf ball over here. It's yelling at us because stuff has changed. So we'll go ahead and we'll just we'll dump this timer and all that stuff. What we're displaying though for now is going to be our game's current distance variable. Okay, so it's just going to consistently show that, and our camera is going to follow the distance. All right. Now, come back here. We'll go into our golf ball. And actually, since the camera is no longer following our golf ball, can't we revert this guy to prototype? He already has. So we took that constraint, or maybe I clicked it when I took the camera follow out. But whatever. So go into golf ball. We're going to add a timer in here. This timer is going to say do something every 1 second. What are we going to do? We're going to change an attribute. What attribute? We're going to change our game's current distance attribute. We're going to change it to whatever it currently is. Plus our game's current ball speed divided by 60 times, what was it, 1760?
Yeah, 1760.
Okay, so same formula we had before, but now we're doing it in the golf ball. All right. Now, the hope is that when our golf ball hits the ground and is destroyed, this timer is also destroyed, and that global variable will not be updated anymore. It will be stuck at the 528 or something like that. Okay? So let's go ahead and hit preview. Nothing's updating now because, as he pointed out, our ball speed is currently 0 until we hit start. So there's our 528. Okay? Now, what would be nice is if we could display this guy truncated, or at least rounded. You know, so we don't have to see 4,000 different, 4,000 different. If you're a golfer, even Tiger Woods isn't measuring things to the thousandth of a yard. Okay, chances are he's probably hitting wedges within, half a yard of each other or something like that, but not a thousandth of a yard. Okay, so let's go into our distance. This guy. Again, we're editing the instance because this is the guy that has the control camera in it. And what we're going to do is before we display current distance, we're going to insert a function. And the function we're going to insert, we could do floor, but I think there's a round, isn't there? Doesn't appear like there is. Precision might make some sense. So let's try adding in the game's current distance and maybe a precision 2. I'm guessing that means 2 decimal places.
Yeah, let's try it.
Seems reasonable enough, right?
Go for it.
Okay, well, so far it seems like we made a good guess. So we'll hit start.
Hey.
Hey, that works.
And we have a long drive competition winner. Okay, so seems like we got something going on here. And maybe we even, actually, this is in yards, correct? Okay. Wouldn't we like it to say yards? I think this is the correct, let's make sure that I've done something. Okay, no, it doesn't like that. It was just a single dot. All right. Well, here. Let me teach about something first, and then we'll go and look up what the correct operator is in Game Salad. So we have this concept called concatenation. Concatenation. Okay. This is, I usually say, gluing 2 or more elements together. Typically, this is used for building a string. So in our case here, we want to take something like 528 and glue onto it the word yards. So that in the end, what's actually being displayed is the value 528 yards for human visual purposes. That make sense? Okay. Now it's possible, so that's what concatenation is. So if we were doing this in Java, again, I want to connect this back to our other languages. If I had a string S and that string was hello, and I had a string S2 and that string was world, and I wanted to create the string hello world, I might say string S3 is equal to S concatenated with the string space concatenated with S2. And that would produce for us the string hello space world. Make sense? So in Java, the concatenation operator is the plus sign. But that's also addition. So in Java, how does it know the difference? If one of the sides of the plus sign is a string, it treats it as concatenation, not addition. Because you're not going to be doing math with strings. Okay? So let's go quickly. I really think it's like a dot or a dot dot. It might be 3 dots.
Worth a shot.
Well, let me take the guess at 3 dots here real quick, and then we'll go look it up. Oh, you're going to Google it for me?
Yeah, that's it.
Yeah, so just do Game Salad Concatenation Operator. No, not that. Here, we'll race. Concatenation. Yeah, it says 2 periods. Okay, then I have another theory here.
Hold on.
Two periods. Let me just try putting double quotes around yards. There we go.
No space though.
Yeah, but space.
I tried to put a space. Trust me, I tried to put a space. How do you add a space in?
Nope.
I didn't even put that. Game salad.
You just do 3 dots and empty string, and then 3 dots, 2 yards.
Well, you don't want the empty string, you want the space string, and it won't let me put a space in. Game salad, string with space. Okay, well, before we even look that up, we're gonna solve this MacGyver style. So what we're gonna do is we're gonna go into our attributes for our distance, and we're going to add a text attribute called suffix. And this guy is going to be equal to space yards. Then we'll go into our instance. And what are we going to concatenate on? We're going to concatenate on this guy's suffix, which should give us a space. There we go.
I'm playing within the matrix.
All right, so we worked within the matrix and we got yards in there. We couldn't create a hard-coded string with a space for I don't know why. Reason-ish. Which. Just keep adding formal. So what did we do? We created a variable. Use that variable to concatenate it. All right, so now we should have something that looks relatively legit. We need to make our box a little bit bigger.
Prototype.
Well, in this case, it won't matter
Yeah.
because any changes we make, we're going to be making to the instance anyways. But it's a good question to ask. Okay. Now, we need to slow this golf ball down so we aren't always hitting it 528 yards. We should be hitting this guy somewhere in the, like I said, 230 yard range or something like that. So that 120 miles per hour needs to slow down. Okay? So let's do that. Just for starters, let's go into our golf ball. And let's create another timer. So this timer is, I'm going to give these guys some names. So I just double clicked on, it just said timer. I'm going to say this is our distance timer. Now I'm going to add another timer in here. And this guy is going to be our ball speed timer. And we're going to say that every 1 second, what happens? Our ball speed I'm going to change attribute. So our game's current ball speed is going to be equal to whatever it currently is minus 10. We'll just say it's slowing down at a constant rate of 10 miles per hour. Actually, we might want to even make it bigger than that. Let's say minus 25. Minus 20.
Could we make it random eventually to simulate?
Well, we'll probably make it more than random. We'll probably go and look up what wind resistance would slow it down. But for right now, let's just see that it has the desired effect-ish. Okay? So every 1 second, we're going to slow down our ball speed by a factor of 20 miles per hour. Okay? Okay, yeah, not that far off.
Before we hit start, it was going backward, right?
Was it?
I think so.
That's because the ball speed was look at that.
Negative.
It's a moving target. Go. Why was it going backwards?
I think it works on the whole of the frame.
Yeah, the golf ball itself moves at a velocity of whatever current ball speed is, right? Okay. So we only want to adjust ball speed if it is what? Greater than 0. Correct? So let's go in and add that. So here's our ball speed timer. So before, here I'll just do this. Then we'll create a rule. Did it put that inside my ball speed timer? No, it wrapped my. Well, actually, this will be fine. So rather than having a rule inside of our ball speed timer, which we should be able to do, I want to do that. So I'm going to create a rule inside our ball speed timer. And this rule is going to say if an attribute, what attribute? Our game's current ball speed is greater than or equal to, well, no, we want it to be greater than 0, right? If it's greater than 0, then change the attribute by minus 20. That way, this timer, it'll start firing every 1 second, but every 1 second it checks. Has the start button been pressed? If the start button's been pressed and the ball speed is now 120, for example, then we're going to start counting it down. Okay, so it's not moving backwards now, but it is slowing down. Okay? So, now we need to figure out how does drag work on this. Okay? So we're going to have a wind input. But before we give a wind input, this way you can say, okay, well, if I'm hitting my golf ball into the wind, because this comes down to, I mean, these are the things that go into play. If you are a golfer and you're hitting a ball directly into the wind, you might want to hit a lower shot so the ball doesn't balloon up in the wind. Okay, but now that's going to start taking into account backspin and all this stuff, things that we're going to maybe find difficult to simulate within GameSolid. But we could potentially estimate it. It might not be real world, okay? But we might be able to get the numbers close enough that a golfer could use this as a comparison tool. So all things being equal, if the wind is in your face and your launch angle's higher, that's going to spin the ball back more, which means it's going to balloon into the air more, so more of its energy is going to go up than out. So as long as we keep those things consistent across all the comparisons, then they should at least be able to make some sort of educated decision as to, given today's wind direction and, 13 of the 18 holes are going to be played into the wind, let's just say. I might choose, and out of those 13 holes, 9 of them are driver holes. Maybe 3 of them are par 3s or something like that, or a different ball, or a different club, like a layup club or something. I'm going to tune my driver down, because all the drivers in golf today are tunable. You have this little wrench thing, and you can change the loft of it. You could do all sorts of crap, but you can't do it during your round. That's illegal. So you can't walk up to the tee box and say, okay, well, this one's in the wind, so we're going to change it up. You got to tune it before you start, and then that's your club, the rest of that round. So you might decide, okay, so because of all these factors, I'm going to go ahead and set my driver, instead of being 10.5 degrees loft, I'm going to set it at 9 degrees loft, because I know that's going to give me a launch angle of like 15, maybe based on what your swing is. And that lower launch angle, instead of being 17, makes the ball actually travel farther. So if we come into our game here, we can already see if we, well, here, let's, so let's see, that would be 150 would be 100 mile an hour. So probably a ball speed for somebody like Tiger Woods would be maybe 175. So let's see how far he'd hit it in our simulation right now. It's not that's farther than he would usually hit it. but you know, it's clearly as we up our ball speed, the ball traveled farther, which is what we're looking for. Okay, so how do we simulate the wind reducing our ball speed? Because the wind becomes our resistance, correct? And wind is going to be a force pushing against it, correct? So what we're going to do is we're going to come up to our game. We're going to add an attribute. This guy is going to be an integer. We're not going to measure wind to the, it's 13.684 miles per hour wind. So we're going to have current wind. And we're going to say a negative wind is into our face. A positive wind is a tailwind. Should help us go a little farther, right? So why don't we, for right now, say we have a wind of -10. And we're going to say this is always in miles per hour. Usually wind is measured in miles per hour, at least here. Okay? So we'll just hard code our current wind to -10. So with a -10 wind, we want to have a force pushing against our golf ball. Correct? But how much does that force? So if I have a golf ball traveling at 120 and I have a force pushing against it at 10, does it slow down by 10 miles per hour? Well, if the force is 10 miles per hour and the speed is 10 miles per hour and you push that against it, how much should it slow down? If I'm walking forward at a constant rate of 120 miles an hour, I know I seem heavy, but I'm sneaky fast. Okay? I'm walking forward at a constant rate of 120 miles per hour, and somebody puts something in front of me that when I run into it, so thinking like football, because we're in the combines right now, right?
Yep.
So you see them ran into things and they're pushing it down the field and that kind of stuff. Somebody puts something in front of me that's going to slow me down. That thing might have a force, they're translating the force into mass, right? So the mass is something heavy that you have to push, and that slows you down because it's harder to push something heavy than it is to push nothing, okay? But if I had something come at me, so somebody tosses a medicine ball at me at 10 miles an hour, but it's a constant rate 10 miles an hour. It's a magical medicine ball, okay? So I have this medicine ball pushing against my chest at 10 miles an hour, and I'm pushing into it. Am I going to slow down by 10 miles per hour? Yeah. I mean, taking all other things out of the equation. We're in a vacuum, blah, 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 all that stuff. 120 plus -10 is 110. Okay? Now, do we even need to calculate this do we need to break this down to how much does it lower us per second? Or since both sides of the equation are in miles per hour, can we just subtract 10? Both sides are already equal. Makes the problem easy for us, right? Okay, so this means that as of right now, we go to our golf ball. And it's, wrong one. ball speed, instead of subtracting 20 to it from it, we'll add our game's current wind. Okay, so right now our current wind is minus 10. Okay, 308 yards with no wind, with no friction, no ball spin. This seems like it's pretty accurate. We're in a vacuum, so backspin and stuff like that doesn't make any difference. Blah, blah, blah. Okay, perfect. Now, if we go into our game and their attributes, and we set current wind to positive 15,
Okay.
boom! No way that golf ball even stayed in. They stayed together. The impact that would cause you to hit a golf ball 3,666 yards. This was fired out of one of those old-fashioned cannons. Okay, so we have an issue. Now, what's actually funny about this is in real life, if I have a 15-mile-an-hour wind in my face, that will have a bigger effect on the golf ball to distance than if I have a 15-mile-an-hour tailwind. So 15-mile-an-hour tailwind will not make me hit the ball as much further as the 15-mile-an-hour wind in my face will make me hit the ball short. Okay, so the wind in your face has a bigger impact. Why? Backspin. So in golf, when you hit the ball, there's going to be backspin. Okay, well, I guess unless you like severely top the ball. So like when you're first learning how to golf and you top the ball a lot, but even then, there's probably still backspin when you top the ball. Okay, very, very little backspin, but still backspin. But a well-hit driver is going to have something like 3,000 RPMs of backspin. So that ball is going to be spinning backwards 3,000 times per minute. Now, when the wind's in your face, that backspin almost hits it like a ramp and balloons it up into the air. So you lose a lot of distance. But the wind's behind you, it's just traveling in that, and it slows down your backspin a little bit. But because the golf ball has such little surface area, it can only have a relatively minuscule effect. Make sense? Now, at this point, we need to start thinking about how can we utilize the tools that are already in GameSalad to help us fake that. Because clearly our current model of saying, well, if wind speed is minus, then it will slow you down by this much in a vacuum. Well, it's accurate right now, right? With taking backspin completely out of the equation, if I am hitting the ball at 120 miles an hour and something's shoving me from behind at a constant rate of 10 miles per hour, I'm going to hit the ball farther. As opposed to it hitting me in the face, right? Part of that is our timer, correct? Our timer only updates ball speed once it's only takes wind into consideration when it gets to 0, right? For ball speed, doesn't do anything once it passes 1,000. Okay. So ball speed's getting a little bit out of hand. How could we better simulate this? At some point here, we want to start transitioning from thinking that we're in a vacuum to at least faking like we're not. And some of these things we're going to do mathematically. We're going to actually solve the math and do it. But some of the other things, we might leverage the idea that GameSalad is a game engine. which loosely translates into it's a physics engine. So it takes some of these things into consideration. It takes things like friction into consideration. So we need to start harnessing some of the tools in Game Salad. For example, if we go into our golf ball, just for the time being, let me click on attributes and let's just set current wind to 0 so it has no impact. Okay. If I go into my golf ball and I go into physics, we see this thing called friction. Okay, we also have rotation, movable, all this other crap. What if I set friction to 0?
No change.
No change. What if I set friction to 5? Should also have no change. Why is that? Because we're not creating an atmosphere where friction can be taken into account. Doesn't matter what the golf ball's friction is if we don't have something for it to rub against. Okay? So we're going to come back on Monday and we're going to investigate friction some. Okay? And then we'll probably have our next homework assignment on Monday. I'll see everybody then.
Monday fun day.
Monday fun day, right?